Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about attributes, sampling distribution and large sample test. Also, we started the discussion about small sample test for single mean. Small sample in the sense when the size of the sample is less than or equal to 30, then it is called a small sample. In continuance with the talk about small sample students t-test for single mean, in this session some problems will be worked out in small sample t-test for single mean and difference of means. Interval estimation in this regard is also done. So, small sample test is a student's t-test. This term was coined by the Professor Gossett, who has given this test in his pen name as student. So, student's t distribution, let xi, I is equal to 1, 2, 3 etc. up to n be a random sample of size n from a normal population with mean mu and variance sigma. The student's t is defined by the statistic t is equal to x bar minus mu divided by sigma by root n. Okay, where x bar stands for sample mean and mu is population mean and sigma is standard deviation of the population and n is the size of the sample. Now, what is the procedure being adopted in students t-test? That is the usual procedure for test of significance. This kind we have already discussed in large sample test. That is step 1 is setting up null hypothesis, step 2 is setting up alternative hypothesis and step 3 is level of significance, step 4 is computing the corresponding statistic and step 5 is conclusion step based on the comparison about the calculated and tabulated values. Now, here there are also fixed null hypotheses and alternative hypotheses and the statistic formula here. Therefore, that we will write down. First step 1, setting up of H naught is fix up the mu value and write down, that is it is like mentioning that the sample has been taken only from the population whose mean is given by the value in H naught. Okay. So, step 2 will be H1 such that mu is not equal to a particular value or it will be greater than a particular value according to the question or it will be less than a particular value, this corresponding mu naught value. Okay, in this case it is called a two-tailed test and these two cases gives you one-tailed test. Okay, step 3 is fixing up the level of significance. Step 4 is computing the t formula. There are two different t formulas based on when the population ST is given and the sample SD is given directly and sample SD is not given directly, where you have to calculate the sample SD using the sample observations given in the question. I will write down both the formula based on the sample standard deviation values known and unknown. So, x bar minus mu divided by S divided by root of n minus 1 if standard deviation is given directly, or the formula is t is equal to x bar minus mu divided by S by root n if a standard deviation is not given directly. Not given directly means the values are not already calculated and given in the question, where you have to calculate the S value and x bar value from the sample observations given in the problem. So, where the formula for calculating x bar is sigma is equal to summation I is equal to 1 to n xi divided by n, and S is equal to root of summation xi minus x bar whole square divided by n minus 1. When the standard deviation is not given directly, you have to use this formula of t. T is equal to x bar minus mu divided by S by root n. This is the formula if a sample SD is not given directly. Not given directly in the sense it is not earlier calculated and the values are given directly in the question, whereas you have to calculate the standard deviation and the sample mean using the observations of the sample given in the problem. So, where x bar is equal to summation I is equal to 1 to n xi divided by n, and S is equal to root of summation xi minus x bar whole square by n minus 1, where this summation xi minus x bar whole square will be done as xi, and xi minus x bar column you have to form, and xi minus x bar whole square you have to form. So, this summation will give you summation xi minus x bar whole square, and this particular summation will give you summation xi, and sometimes this must be equal to 0, and due to approximation it may be nearly equal to 0 also. So, then only we are doing the problem correctly. Okay. So, after computing the statistic, next step is comparison step. So, step 5 is calculate t at the level of significance fixed in step 3, and also the degrees of freedom for the small sample test. Okay, that you should write it within modulus, and then tabulated t you must write from the tables given to you, that is t tables for two-tailed test. As we were discussing previously in large sample test, when the table is for two-tailed test, and if you, for example, if you want to refer for 5%, directly you can refer at 5% in two-tailed test table, whereas for one-tailed test and the table is two-tailed, then you have to refer the values of 5% for one-tailed test at 10% in two-tailed table. So, after this comparison, where calculated value is less than tabulated value, H naught is accepted, and if calculated value is greater than tabulated value, H naught is rejected. H naught is rejected in the sense H1 is accepted. So, when H naught is accepted, you have to write down the statement of H naught as a conclusion, and when H naught is rejected, we have to write down the conclusion as the H1 statement. Next, what are the uses of t-test? This statistic t is used in the following situations in test of hypothesis. Like large sample Z test is used for testing single mean, difference of means, t-test is also used to test whether a specified value of the population mean when the given sample is a small sample and the population SD is not known. It is also used to test the significance of difference between the means of two populations based on two samples of sizes n1 and n2 when the standard deviations of the population are not known and also the samples drawn are independent. And there is one set of observations called paired set of observations, in the sense the same sample will be taken before a kind of treatment from the population, and the same sample will be taken after the treatment from the population. So, the samples are different with respect to the treatment. Sample 1 will be the before treatment and sample 2 will be after treatment. This kind of samples, this kind of pairs of samples will be called as paired observations. So it is also used to test the significance of difference between the means of paired observations. Now a t-test for specified mean. Given a random sample of size n less than 30 with sample mean and x population mean has a specified value, then we apply the same procedure as in the case of large sample. Thus we have discussed the t statistic follows the t distribution with number of degrees of freedom r is equal to n minus 1. This is the degrees of freedom as I was discussing in the calculated value part. We compose the calculated value of t with the tabulated value of t for n minus 1 degrees of freedom for a given significance level. If the calculated value of t is less than t naught, the tabulated value of t h naught is accepted, and if the calculated value of t is greater than t naught, the tabulated value h naught is rejected. This is the two-tailed test tables given to you, and you have to refer the tabulated value from this tables. This is actually significant values of t alpha. These are the degrees of freedom given to you, and these are the levels of significance. This is a 50% level of significance, this is 10% level of significance, and this is 5% and 2%, 1% and 0.1%. And this, as I was discussing, this is a two-tailed area. Okay, there is also a separate table given to you for one-tailed area. Even if it is not specifically given, the two-tailed table can be used for one-tailed test, as we were discussing in one of the previous slides. After discussing about the small sample t-test for specified mean, we will work out this problem. So 16 examples have been worked out in test of significance. This is 17th one. A sample of 10 house owners is drawn and the following values of their income are obtained. Mean is rupees 6,000 and standard deviation is rupees 650. Test the hypothesis that the average income of house owners of the town is rupees 5,500. There is a house owner sample has been taken, and the house owner's sample size is 10. Sample size is 10 implies this whole problem or this case study is about small sample. So we have to apply the small sample test. There are various small sample tests, T, F and chi-square. T is specifically for testing mean, whether it is a single mean or difference of means. So this particular problem is testing the hypothesis of the average income. Average income means mean. Therefore, like this kind of identification you must initially do for any particular case of a problem. Okay. So what is the identification we are doing here is starting the solution. First identify and decide what type of test is this and what type of statistic it follows. Okay, the first identification is you have to take n value. N is 10, which is less than 30. Therefore, you have to decide this is a small sample test. Since there are various tests in small sample, this kind of identification is necessary for small sample. Whereas in large sample, we have studied mean test and proportion test and a standard deviation test. So according to the question, you have to decide what type of test we have to use in large sample also. Then the second identification is what type of test is this? This is a mean test. As we were discussing in small sample test, there are three types of test. One is mean test T, and another one is variance test F, and another one is frequency test chi-square. So here this is mean test in the sense it is T test. Okay. Third identification is whether it is a single mean test or difference of means test or it is paired observations. It is based on the sample given in the question. So a single mean test in the sense only one sample has been one type of sample is taken from one population. Okay. Therefore, it is a single mean test. If two types of samples are taken from two different populations, then it will be difference of means test. And if the samples are taken from the paired observations, then it will be called a paired t-test. So, after identifying this single mean test, we will get into setting up the hypothesis and then computing the statistic. So, step 1 is setting up of H naught mu is equal to 5500, that is population mean value, right. Test the hypothesis that average income of house owners of the town. House owners of the town is considered as population and is given to be 5500. It means that average income of the house owners of the town is 5500. So, step 2, H1 will be mu is not equal to 5500. So, the average income of the house owners of the town is not 5500. Step 3, we fix up the level of significance %. Now, at this stage, step 3, you have to mention the degrees of freedom also. Degrees of freedom. Degrees of freedom is given by the formula n minus 1. What is n here? N is equal to 10. Therefore, degrees of freedom, shortly DOF, is equal to 10 minus 1 is equal to 9. Okay, so degrees of freedom was not discussed in large sample because of the sample size is very large, and after 30 the sample size is considered to be infinity. Therefore, degrees of freedom also will be infinity. Next, step 4 is computing the statistic T. Here all the values are given directly. So, we use the first formula of T. T is equal to x bar minus mu divided by S divided by root of n minus 1. So, the value is where x bar value given in the question is 6000 and standard deviation is 650. X bar is 6000 and S is equal to 650, N is equal to 10, mu is equal to 5500. So, substitute all the values. 6000 minus 5500 by 650 divided by root of 10 minus 1. It is 500 into root 9 by 650 is equal to what is the value? Root 9 is 3 and this value is 2.308. Okay. So, T is 2.308. The value which you got 2.308 should be written in this format, that is calculated T at 5% comma 9 degrees of freedom. The degrees of freedom should be written along with the calculated value, so that you will be able to take the tabulated value from the tables corresponding to the specified degrees of freedom. So, calculated T at 5% comma 9 degrees of freedom is equal to 2.308. Then tabulated T at 5% comma 9 degrees of freedom is taken from the tables. Now, refer the tables which you have seen in the previous slide. Degrees of freedom is 9 and the level of significance is 5%. Therefore, this 2.26, isn't it? 9 degrees of freedom and the level of significance is 5%. This is the tabulated value for the T at 5% and 9 degrees of freedom, right? 2.26 from the tables. Calculated value is 2.308 and tabulated value is 2.26. So, the calculated value is greater than the tabulated value, therefore, H naught is rejected. Calculated T at 5% comma 9 degrees of freedom within modulus is greater than tabulated T at 5% comma 9 degrees of freedom. Okay. This is actually step 5, conclusion based on comparison. So therefore H naught is rejected. When H naught is rejected, H1 is accepted, in the sense that the average income of house owners, whole house owners of the town is not 5,500. This is the conclusion we draw from this problem. Next example is, if a random sample of size 10 from a normal population standard deviation 5.2 shows a mean of 16.9, test at 5% significant level that the population mean is 15.5. Also obtain 99% confidence limits for mean. Okay. So what are the values given? Like we were discussing in this example 17, you have to do the identification. First of all, this is a small sample because of size is 10. Then second is it is a mean test, because you are asked to test whether the population mean is 15.5. So second identification, it is a mean test, so T test. And then third identification is it is a single mean test, right, because of one sample and one population. Okay. So going ahead and similarly solving like previous problem, we will test the hypothesis, and at the same time you have to calculate 99% confidence limits for mean. Now, since you are asked to calculate 99% confidence limits for mean and the level of significance is not specified, we shall take up the level of significance as 1%, because 99% confidence limits, if we want a 1% level of significance, we have to fix. First of all, let me write down all the values. N is equal to 10 and S is equal to 5.2 and X bar is equal to 16.9. And the identification says you it is a small sample first, and then it is a mean test, and third identification, it is a mean T test, it is a single mean test. Okay. So step 1 is setting up of H naught. I will just go quickly, because this type of problem already we have done. This problem is mainly concentrated for calculating 99% confidence limits, because all the other procedures are same. Mu is not equal to 15.5. Step 3, level, I shall shortly write LOS, level of significance is 1%, and degrees of freedom, DOF, degrees of freedom is n minus 1, n is 10, so 10 minus 1 9. Step 4 is calculation part, T is equal to x bar minus mu divided by S divided by root of n minus 1. It is x bar is given in the question is 16.9 and mu is 15.5 divided by S is 5.2 divided by root 9, and this value comes to be equal to 0.8076. So calculated T at 1%, 9 degrees of freedom is equal to 0.8076, and tabulated T at 1%, 9 degrees of freedom is taken from the tables at 1%. 1% is here and degrees of freedom is 9, so it is 3.25. 3.25. Calculated value is much lesser than tabulated value, therefore H naught is accepted, that is population mean is 15.5 is accepted. Okay. Now we will find out the 99% confidence limits we have to calculate. We again use the formula T at 1%, 9 degrees of freedom is equal to x bar minus mu divided by S by root of n minus 1, because 99% confidence limits implies 1% level of significance. Okay. So this is T value at 1%, 9 degrees of freedom. This is from the tables you have to take tables. this is 3.25, x bar value is 16.9, mu only we are calculating, and then s value is 5.2 divided by root 9. Just cross multiply 3.25 into 5.2 by 3 is equal to 16.9 minus mu. We have to take up this plus or minus value because of the modulus we are taking. Okay. So, mu is equal to 16.9 plus or minus 3.25 into 5.2 by 3. So, the values are minus 22.533 and 11.267. So, this is the 99% confidence limits. One value with plus and another value with minus. Confidence limits are minus 22.533 and 11.267. So, in this session we were discussing the small sample. So, some problems have been worked out in small sample t test for single mean after discussing the procedure for single mean, and interval estimation is also done in this regard. Based on the discussion in this session, the following questions may be posed. Brief small sample t test for single mean. In this particular question, you have to discuss the procedure adopted for testing the single mean in small sample case. Then for a random sample of size 10, the mean is 106 and standard deviation is 10. Is it reasonable to assume that this sample came from a normal population with mean 100? You are asked to test whether the population mean is 100, or is it a sample taken from the population with mean 100, and this tabulated value is also given, that is t at 0.01 is 2.82 for 9 degrees of freedom. Actually, when the sample size is 10, degrees of freedom is 9, and the two values are given to confuse you. Actually, you have to take only this particular value. T is equal to 2.76 for 10 degrees of freedom, whereas degrees of freedom is 9. You usually instead of giving the tabulated value directly, two values will be given. You have to choose from that. You have to choose the correct one from that. Thank you.